If you live in the United States and are using a receptacle tester to identify a wall outlet wiring problem, you may not understand the terminology used to identify the type of fault listed on the tester's legend. I'll explain the fault conditions and give some suggestions on how to fix them. Let's look at a diagram to see how an electrical outlet should be wired. This is a simple circuit that just has one outlet wired to a breaker at the main circuit breaker panel in your home. This is a piece of NM cable. The NM stands for non-metallic, and that refers to this plastic sheathing on the cable. This is the type of cable that you would typically find in a residence starting in the 1960s in the United States. It has three conductors: a black, that's the hot wire; a white, that's the neutral; and this bare copper wire is the ground wire. In 1962, the code mandated a ground wire be used on branch circuits. The hot wire is connected to the gold screws on the outlet. The gold screws connect to this smaller slot on the front of the outlet. The white or neutral wire connects to the silver screws on the side of the outlet, and the silver screws are connected to this longer slot on the face of the outlet. The bare wire, that's the ground wire, which can sometimes be colored green, is attached to this terminal with a green screw. The green screw is connected to the ground prong hole on the face of the outlet. Ensure that the tester does work by plugging it into a known good receptacle. Let's tackle the easy problems first. If the fault is a hot neutral reverse, a hot ground reverse, or an open ground, leave the tester in the outlet that you're working on. Turn off power at the breaker. If no lights are lit on the tester, you found the correct breaker. When working with electricity, it's always a good practice to wear rubber-soled shoes. Remove the cover plate and the receptacle from the box. When pulling the receptacle out of the box, don't grasp it between the hot and neutral screws. Power is supposed to be off, but you should always treat it as if you could have live power inside of the box. Grasp the receptacle on the plastic parts and pull it out of the box. Examine the wires that are connected to the receptacle. If the wiring in your cable is not a copper color and it is dull and silver, and your home was built or added onto between 1965 and 1973, then it is likely you have aluminum wire. For many reasons, aluminum wiring connections can become loose and cause a fire. If you think you have aluminum wire, the connections must be dealt with in a special manner. I strongly recommend that if you have aluminum wiring, you contact a professional electrician. If the fault was a hot neutral reverse, you're likely to find that the white wire was connected to the gold terminal and the black wire is connected to the silver terminal. You simply need to swap the white and the black wires so that the hot wire is connected to the gold terminal and the white neutral wire is connected to the silver terminal. If the condition was a hot ground reverse, you're likely to find that the black wire is connected to the green ground terminal, and the ground wire is connected to the gold terminal that corresponds to the small hot terminal of the receptacle. Simply reverse those two wires to correct the problem. If the fault was an open ground, it's likely that you won't find a ground wire connected to the green grounding terminal. If the cables coming into the box do have a ground wire, then run a new ground wire from the green ground terminal on the receptacle and connect it to the other ground wires in the box. If the box is metal, ensure that there's a ground wire that goes from a screw on the metal box to the group of ground wires inside of the box. They all must be bonded together. If there is a ground wire on the green terminal of the receptacle, ensure that all the ground connections are tight. If that checks out, then most likely the grounds coming in to the box are not tied to ground someplace else. If the cabling in the splice box does not have a ground wire, then someone has replaced the original 2-prong outlet with a 3-prong outlet and not connected a ground wire. This is a code violation. 2-prong outlets are no longer available. To meet code, you must install a new cable with a ground wire or install a GFCI outlet. If the fault was open hot or open neutral, then you're missing power on either the hot or the neutral wire. If you've lost power at just one outlet, then check that the connections are secure on the hot and neutral. It is possible that the outlet has broken internally and you need to replace it. If you have multiple outlets and lights that don't work, then the problem could be somewhere else and you'll have to trace out the circuit. If you've recently had some work or construction done in your home, you may want to check that area. Perhaps something was not reconnected, or maybe wiring was damaged. I hope you found this video helpful. A thumbs up is always appreciated. Click on the channel name, Know How Now, to find other videos, and thanks for watching.